I tripped over in the garden and I've got a terrible scratch on my nose, so I have to be this way around, so it's not so bad this side.
You're okay now.
Sorry?
You're okay now, right?
That's because it's covered up.
Great.
Good morning, Rajaman. Would you like to introduce yourself and tell us about the work that you're doing at the university?
Yeah. Good morning, well. Yeah. I'm Raghavan Chinnambedu Murugesan, Research Associate at Aston University. And my research is right now is focusing on honey quality assessment and adulteration monitoring.
So what are you using for this?
So I'm using a fluorescence spectroscopy to assess the quality of honey. So this fluorescence spectroscopy is simply light matter interaction. So when you are shining the light on honey, you are getting the information of spectral fingerprints. So by assessing the spectral fingerprints, you can say whether it is good quality honey or not. So, and then you can assess various chemical constituents, minerals, nutrients, and other vitamins in the honey samples. For instance, we have the spectra like this. So here we have the fluorescence spectral results for the borage sample. So this is the borage samples harvested under different climatic conditions. One is pure white borage, and you have the yellow borage honey. So why we have these two different colors? We examined using fluorescence spectroscopy, and we found that the white borage, it has the dominant polyphenol components.
Hold on a second, let's just focus on the... Now, borage honey is quite distinctive. It's a very pale, quite a, it's a not a very thick honey. It's quite very distinctive.
Yes.
And so you say this one was particularly a pale, normal-looking sample.
Yes, exactly. So here we have polyphenol rich. This means that the polyphenol is basically antioxidant. It is very important for our health, and that is rich in there. And here also we have polyphenol components along with other nutrients, and that is the colors that is the responsible for the yellowish color in this borage honey. So you can see this flavonoid is quite intensive here. So
there's been quite a lot of work going on.
Yes. For instance, you can see here the spectral comparison of this yellow and white borage actually. For the white and yellow borage, the polyphenol component is quite same, but in the case of the colors, why the yellowish color, the intensity difference? For the white one, you have low intensity. The red color of this curve is representing the white borage honey, and the black color is representing the yellowish one. The intensity, the color intensity is quite high for this yellowish that you can easily identify. This means that you have the pollen impact on this yellowish borage honey. So you can distinguish that.
So you can distinguish whether the yellow is just that it is not monofloral, that the bees have been foraging on something else, or whether it's adulterated with something that shouldn't really be there.
Yeah, so this yellowish, sometimes it may be the artificial color can also create this kind of effect. But you can see when it is artificial colored, this one clearly shift the peak. But in this case, we don't have such a peak shift. This is because of these two different climatic conditions, harvesting climatic condition, that makes this difference in color.
So you can tell by the peak shift whether, or rather that you can identify the source of the coloration.
Absolutely. The botanical origin you can identify.
Right.
Yeah. And another important applications what we are doing is, so the adulterated and fake honey, actually. Sorry, the real honey and the fake honey. For instance, we have natural real honey, borage honey here. and the fake honey here. You can see the clear spectral difference between these two. For instance, in the case of natural honey, you have this antioxidant, polyphenol antioxidant is quite rich. But when it is adulterated with artificial sugar, then you have this complete suppression of the peak intensity actually. And you don't have any peak corresponding to this 330 nanometer, which is polyphenols. You can see it is completely quenched. So this is the way we could able to differentiate natural honey and adulterated honey. In addition, under Innovate UK project, feasibility study analysis with the British Beekeepers Association and then Honey Authentication Network and Scottish Bee Limited, we jointly worked together and to combat this honey adulteration actually. So there, the task is to collect number of honey from different origin of UK and worldwide and get the spectral database and apply machine learning and distinguish and discriminate different types of pure honey and adulterated honey. So we already successfully demonstrated this 100% discrimination of pure and adulterated honey with hundreds of samples with the collection with the help of collection from a different origin with the help of BBKA and National Honey Authentication Network and Scottish Bee Limited. So they supported to collect authenticated honey certified with different laboratories. Then we use that as a standard database to assess adulterated honey.
So is developing the AI and the machine learning part of your role as well?
Yeah, absolutely.
So you're helping to develop the future
Yes.
of being able to detect.
Yes.
So tell us how this is going. How is this going to help the individual beekeeper?
So at present, we are using this bulk spectrometer and we are planning to develop portable spectrometer for the beekeepers. The portable spectrometer
There's obviously a lot of work being going on here, and this is the ultimate aim.
Yeah, this is the portable spectrometer we are planning for the beekeepers. So it has a low-cost spectrometer, which costs about 700 pounds, but they can use for their lifelong.
So which unit is that on the
This
diagram?
one is the one which is the red box, the small box.
Right.
That's the portable spectrometer, and you have a simple sample holder, and you can put your honey sample there and use your LED light pen and shine on the light on your honey sample, and you can get the spectral information. And that one, so we have the standard database at Aston University, and you can, using this telecom advancement, you can compare the database which is in the Aston University and this one to assess the quality of the honey. So this is definitely one of the best support for the beekeepers. They can do their assessment in their own form without any laboratory analysis, because laboratory analysis, it is quite expensive and it needs a sophisticated person to examine your sample and time consuming analytical procedures involves. But in this case, you have simply shining the light on your sample and getting the molecular fingerprints and analyzing your quality.
And is this available yet, or are you hoping that this will be developed commercially?
Yeah, right now this technology, we have the proof of concept for the particular wavelength, the dominant wavelength. We call it as a light frequency. So shining light frequency, okay? So we are developing for different LED. Yeah. And the principle behind this, do you understand the principle behind this light matter interaction?
Indeed.
Yeah, this is very simply speaking. So while you are shining light on the sample,
right?
So what it will happen, you have different chemical components in the honey, right?
Yes.
So different chemical components, it will respond different frequencies of light. So each frequencies will have its own characteristic signal. That's what we had seen in our previous spectrum. So for instance, this is the frequency for the polyphenols, and this is the frequency for the polyphenols for the pure one and adulterated one. So you can compare, right? So these frequency changes, these frequencies of light response, you can assess 100% quality of the honey.
And are you hoping to develop something that's even more portable, even simpler?
Yes. So our final task is to transfer this technology into the mobile phone. lab in your pocket. So you can use your mobile phone, and using the camera light flash, you can shine on honey sample and get the information from there, and you can compare the database and assess the quality straight away. So you can go to supermarket and collect the honey and shine using your mobile phone camera flash, and then get the information and assess the quality, and you will be more confident that, okay, I have good quality honey to consume, so I'm 100% confident so to consume this one.
So are you looking for companies to help you develop this?
Absolutely. So we are looking for funding support to involve a lot of research in there, and to develop this, advance this technology into the mobile level, actually.
So that sounds like fun. And are there other applications in other aspects of the industry?
Absolutely. This particular technology we can use for various food industries, like dairy industries, oil industry. For instance, the first most adulterated oil is olive oil. So people are using this technology to assess the quality of olive oil, and that's 100% beneficial for the consumers as well as sellers, right? Like, for instance, so whatever we are paying for getting this high quality olive oil, it is worth to get it. So we need to have such a confidence to consume that one, right? So this technology will give consumer boost that, okay, we are 100% good to access this one. Yeah.
So that is all really interesting, with a lot of applications, not just in the beekeeping industry, but elsewhere as well. So I hope you've had a lot of success. I hope that you're talking to lots of people here at the show, and I'm sure they're showing a great interest, not only in what you're doing now, but the